Okay, 5.7, graphing exponential functions. You'll notice if you've looked ahead in the notes, 5.8 is going to be graphing logs, but for now we're just dealing with when we're graphing the exponentials. So we have a function like this. Okay, this is just the equation that we use. You'll notice there are some letters that are circled that we've seen before. H and K. What does H usually mean? It means what? Left or right, up or down? Left, right. Yep. So horizontal shift. H tells us left, right. K tells us up or down. So this is going to be the exact same thing that we always fill in. H is horizontal. K is vertical. H is a little bit deceiving, so if it's positive, that actually means to go left. And if it's negative, that means go right. But K is the same, so if it says positive, it means up, and negative means down. Anybody remember what happens if the A value is negative? Yep, reflects or flips across the x-axis. Good. If A is bigger than 1, that means it's a vertical stretch. And if it's less than 1, that means it's a shrink. Same thing as always. Okay. Real quick, just look at this equation before we move on from it. Do we all see how B is the base? Yes, the base of the exponent. That's what we call letter B, okay? Do we notice how A is the number in front of it? Yeah. Okay, so the only time you're going to have a stretch or a shrink is going to be if there's a number out front. The B value is not the stretch or shrink. Okay, so if B, for instance, is 2, your base is 2, that does not mean it's a stretch. Are you with me? That just means your base is 2. Okay, but if it's 5 times 2, then it would be a stretch. You with me on that? Okay, and once we get going on these, that'll start to make sense. Asymptote, okay? For these, the asymptotes, we always know that that's kind of like a wall that we can't touch. A wall that we can't touch. We might get super duper close to it, but we're never ever going to touch that. It's a wall or a line that we cannot touch. When we are graphing exponentials, this is super important. When we are graphing exponentials, there's always going to be a horizontal asymptote. Okay, so it's always going to be y equals k. This is super important. The horizontal asymptote is always going to be y equals k. If there's no k, it would just be y equals 0. Okay, there will never be a vertical asymptote on exponentials. So no vertical asymptote on exponentials, only horizontal. So wait, you're telling me I can write none and all the vertical asymptote blanks and I'd get a point? Yeah, that is pretty sweet. Okay, another pretty sweet thing. Notice what the domain is. Negative infinity, positive infinity. That's always going to be the domain on these. Okay, we like that. That makes it simple. Just like quadratics and absolute values, right? That was always the domain. Okay, range, the only thing you have to worry about is the k value. Okay, because again, there's a horizontal asymptote. There's no holes on these. There's no crazy things. Okay, so really graphing these should be pretty straightforward. I think you'll actually think it's pretty easy. So we're going to go ahead and go to this first one. We'll first just look at that equation. It says f of x equals 3 to the x power. What's the base? All right, so we got 3 to the x power. We said 3 is the base, okay? And what's the power? Just x. So we're going to go ahead and fill out this t-chart and just tell what y would be if x were -2, -1, 0, 1, and 2. So I want you to go ahead and do that. Use a calculator, type it in, 3 caret, and then type in that exponent. Hit enter. And then go ahead and plot all of those points. All right, when we type this in the calculator, when we put 3 to the -2nd power, what do you get? 0.11. Okay, negative 1, 0.33, 0, 1, and 2, 9. Okay, so then we want to go ahead and plot those points. So negative 2.1, negative 1.3. Just try your best on these guys. Okay, so there are my points. Okay, and the next thing I want to look at here, and I could have done this before I graphed it, it might have helped me visualize this a little bit better. But if I look, what's the K value on this? 0, okay? There isn't one, so that just means that my horizontal asymptote is y equals 0. Will there be a vertical one? No. Never. Okay, on these there's not going to be a vertical one. Okay, so now what I'm going to do is I'm going to go ahead and I'm going to graph that horizontal asymptote, just so I can see what that looks like. And again, we've talked about this before, but I just kind of want to reiterate. The purpose of an asymptote is that it's like a wall, okay? It's a big hole in your graph. I can get super duper close to that line. I'm going to. That's the whole point of it. But I'm never actually going to touch that line, okay? So when I graph this, it's going to look something like this. Hold up. Right? And this line's going to keep on going forever, and it's going to keep on getting as close as it can to 0, but it's never actually going to equal 0 because it can't cross it. Does that make sense? Okay, so it's going to look something like that. The domain is always going to be, yep, and if I look at that, I got 2 arrows going left forever, right forever, so that makes total sense, okay? Now I look at the range, okay? And if I look at this, so from the bottom to the top, where's this actually starting? Wouldn't it be starting like super duper close to 0? Like above it, okay? Which actually it's not going to be 0.1 because I could keep on putting numbers less than 2 in and I would get even closer to that line than 0.11. But actually what we can do to define this is we can put that horizontal asymptote number with an open parenthesis because technically that means we don't equal 0, right? But we'd go from 0 to positive infinity, and that would be the range. So it's always going to be from your horizontal asymptote to infinity. That makes sense? You can see that? So from bottom to top, that's where we're starting and that's where we're going. Okay? Limits. So limits for the x approaches, negative infinity, positive infinity, just like always. Okay? And then we have our y's. So if we think back to the last thing that we graphed, the y's went to the horizontal asymptote, okay? This is going to be similar, but one of them is going to be different. So if I look at this graph, okay, so as I'm coming in and I'm approaching the left, so as x goes left, what's y doing? Isn't it stopping at 0? Yeah, so it's going to go to the asymptote as x goes left. But now if I look, and as x goes to the right, what's y doing? Going up to infinity. Okay, so these are actually never going to match. Okay, one is going to go to the asymptote and one's going to go to infinity.
So it's always going to be the range?
What'd you say?
It's going to be the range?
Yeah, it's always going to be the range, but you got to make sure you look at it because we're going to see that this line could go the opposite direction as well, so it might flip those. Okay? All right, and then we've got increasing and decreasing intervals. It's only going to be one or the other. From left to right, what's this guy doing? Increasing, so I just rewrite the domain, so negative infinity, positive infinity, none for decreasing. And then x and y intercepts. Does my t-chart give me one of them? What is that? The y-intercept. And if there's an asymptote at at y equals 0, am I ever going to touch the x-axis? Nope. So there's going to be none on x-intercepts. Okay, was this hard? No. Was it tedious? Yeah, but all graphing is, right? Okay. We'll keep going. I want you to go ahead and try this one. Okay, make sure when you type in those exponents in your calculator that you type it in like this. 3 caret to the negative 2, close that parenthesis before you plus 5, because otherwise it's going to count it wrong or give you the wrong number. Okay, so go ahead and try that. Go ahead and start graphing it. Get as far as you can on those blanks, and then we'll go over it. All right, let's go ahead and get started on this one. What did you put in for your T-chart? What numbers did you get out? For negative 2, 5.1. For negative 1, let's see. So what? 5.3. For 0, for 1, 8, and for 2, 14. Cool. Okay, if I look at this one, what is the K value? 5, so that's going to be my horizontal asymptote. X equals 5 or Y equals 5? Y equals 5. Is there a vertical asymptote? Nope. Alright, so just before I graph this, sometimes I like to just go ahead and graph the asymptote before I start graphing the line, just because that helps me to visualize. You don't have to, but that's what I do. Negative 2, 5.1, then we got 5.3, 6, 8, and then it looks like this is going to go off my chart a little bit, which is fine. And it should look like this. Raise your hand if you got that one graphed. Good deal. Okay, awesome, everybody. Domain is going to be what? Range? Perfect. Limits. Yep, so as x goes to the left, y is stopping at 5, and as x goes to the right, y is going to infinity. Increasing or decreasing? Increasing. X-intercept? None. Y-intercept? 0, 6. Cool. All right. So then the last thing it says is identify the shift compared to the parent graph. So looking at this one, if I just made a parent graph of this equation, it would just be the base with the exponent of x. Okay, so if I look at that, 3 to the x power would be the parent graph. What did this 5 do? Made it go up 5. So my shift would just be up 5. Okay, I didn't have an a value, I didn't have an h value to worry about. Just had base with the exponent and a k value. Okay. Number 3. If we look at this one doesn't give me a T-chart, okay? But what you're going to notice is anytime that your exponent is just x, if I set that equal to 0, what is it? X is 0, right? So 0 is always going to be that middle number, okay? If, for instance, my exponent, let's say that instead of x, let's say that this exponent was x plus 2. If I set that equal to 0, what would that be? Negative 2, so I would make that my middle number in my table, just to help me build, okay? But since this one just has x, it's just going to be 0. So 2 things to the left of 0 would be, and 2 things to the right, 1 and 2. Okay, which are the same numbers we used for the other tables as well. All right, so go ahead and try that one. Get going on this one. When we plug in negative 2, what do we get? We got 4? Okay. So we got 4, and then we got, and then we got, and then we got, and then? Okay, you're good. All right. So now we plot these points, right? My asymptote on this one is at 0. No vertical asymptote. So that makes sense that my points are all getting close to that axis. Okay, raise your hand if you got something like that. Cool. Domain. Range. So it's still going to be 0 to positive infinity, okay, because range is the y values. So that one's not going to change, okay? Don't change the range. Then we've got our limits, which these might change, okay? So if we look as x goes to the left, what is y doing? It's going up to infinity. And then as x goes to the right, now where's y going? To 0, to the asymptote. Okay, so those did flip. Is this increasing or decreasing? Decreasing. X or y intercept? We got a y-intercept, but not an x one. What is the y-intercept? Perfect. Raise your hand if you scored an 80% or better on that problem. All right, cool. Any questions on that? Okay, before we move on, what do we notice about that graph compared to the ones that we just did? From left to right, we're going down, right? So it flipped. What do you think made that happen? The 1/2. The base was 1/2. Do we see that? It was a fraction. Okay? So when the base is a fraction, or when it's less than 1, we're probably going to get a line that switches. Let me show you the reason for this. Okay? So let's say, for instance, that I had 2 squared. Or not squared, 2 to the x power, I mean. Okay? Which is just the reciprocal of that. You with me? So if I were to plug in these same numbers for x, y, so -2, -1, 0, 1, and 2. So go ahead and plug in -2 for me. What is 2 to the -2? 0.25. What's 2 to the -1? To the 0? To the 1? 2, and then to the 2. What do you notice about those numbers? It's flipped, right? Which makes sense because it's a reciprocal, right? So that is how we do that. If the number's less than 1, it's going to be going the opposite way, okay? If it's bigger than 1, it's going to be going up. Make sense? But technically, that's still our base number. Are you with me? It's not the a value. It's still the base number. It's not the a value. Okay? Questions on that? Cool. Number 4. All right, what do we notice about number 4 that we've not seen yet? X plus 5, which is the H shift is what we call it, right? Yeah, okay. So the H shift really matters for one thing on these. Don't get confused and think that the H shift is a vertical asymptote, because it's definitely not. Also, don't get confused and think it's a horizontal asymptote, because that's still our K value, which on this one is 0. Okay, so we still got that going for us. Okay, but what the H shift actually tells us is just where to start building this table. So I set that equal to 0, and what does x equal? -5, that's going to be my middle point of my table. That's really the only thing good about that H value. It's the only thing it's going to do for me. What are 2 things to the left of -5? 2 things to the right? Perfect. And now go ahead and plug those in. And make sure on this one when you type this in, you would type 2 caret, and then you type -7 plus 5 in the parentheses. Okay, because again, that plus 5 is a part of that exponent, so it needs to be in the parentheses with that number. And tell me what you get for that first one. 0.25. Okay. And now type in negative 6.5, negative 5, negative 4, and negative 3. Cool. So we'll go ahead and plot those. Okay, so it should look something like that. Domain on this one. Negative infinity, positive infinity, range. 0 to infinity. Limits. So as we go to the left on the x-axis, what's y gonna do? Yep, gonna level off at 0. And as we go to the right, infinity. Is this increasing or decreasing? Increasing the whole time. Never decreasing. X-intercepts. Is it ever going to cross the x-axis? Nope, because that's an asymptote. Ooh, y-intercept. What about that? 32. How'd you get that?
Plugged 0 in the x.
Yeah, you just got to plug in 0 for x. Okay, and she got 32. 0, 32. So write that down if you won't remember that. Plug in 0 for x, even though we've been doing that for a very long time. So we should be good on that. Any questions? Okay, and then lastly, identify the shifts compared to the parent graph. What would the parent graph be on number 4? What's the base? 2, just to the x power if it's a parent graph. So what did we do here? We had a +5, which told us that's our H shift, right? Which meant to go left. How many? 5. Does it look like that graph shifted left 5? I think so. It's over in that other quadrant, right? Yeah. So left 5. And that's it. Any questions on that? We feel pretty confident about this? Okay. Only got a few more. Okay. So we've got 5, 6, and 7, I believe. Yep, 5, 6, and 7. So I want you to go ahead and do 5 and 6. I'm going to give you about 5, 6, 7 minutes here. And then we're going to do those together and do number 7 together. And we'll call it a day. Let's go ahead and get started. All right, number 5. How did we build our XY chart? You just did what? Good. Yep, x is the exponent, so we just can do our typical 5 numbers. 0 with the middle one. What do you get when you plug in -2? 7? Everyone get 7? Okay, good. What about -1? 0? 1? 1.6? And -1.8. Cool. Anybody get anything different? All right, I like it. We'll go ahead and we will plot these numbers. Okay. What did you then put for your asymptote? What'd you say? For which one? Horizontal, what'd you put for vertical? NA. Good. Okay. So if we go ahead and we plot that, our graph lines up pretty good with that asymptote. Domain on this one? Range? -2 to infinity, good. Again, that asymptote is below that x-axis, so make sure we do it at that number. All right, and then our limits. Yep, so going to the left on the x-axis, y is going up forever to infinity, and then going to the right, it's stopping at -2. Increasing or decreasing? Would you write on decreasing? Okay. X or y intercept? We got a y-intercept where? 0, -1. Okay. Did you put an x-intercept? But is there one? On this one, there is going to be one, okay? Because we can see that it does cross that x-axis, but we don't know where, okay? It's going to be 1 point something or negative point something. We know it's going to be between these two, right? Yeah, okay. So if we had to figure out an exact location for that, how would we find that mathematically? Plug in 0 for f of x. Good. I'm going to show you how easy this is. So we got 0 equals 1/3 to the x power minus 2. Okay, this is what we did a couple class periods ago. Okay? We need to get the exponent and its base on one side by itself. Everything else needs to be on the opposite side. Add the 2 over, good. So now 2 equals the base with its exponent. I'm golden. Now I can set up a log. Log, my base you said was what? 1/3 of what number? Equals x. And I can solve that pretty darn easily in my calculator by just typing in log of a, which is 2, divided by log of b, which is 1/3. Make sure you close the parentheses on the 2. Log 2, close parenthesis, divided by log 1/3. 0.631. So 0.631, comma, 0. Easy as that. No factoring required. Just logs. Okay, and lastly, the one thing it does ask me is what is this going to be, or what's it going to do compared to the parent graph? Just down 2. Yep, that's it. I don't have to worry about anything else. Down 2. Questions, questions, questions. Raise your hand if you feel like you scored an 80% or better on that. Okay, good. All right, number 6. This looks fun. No? We didn't think it looked fun? Okay. Just by looking at this, let's just go ahead and just kind of talk through these components. There's 4 out front. What's that going to be? The a value, right? It's going to be the number out front. We haven't seen that yet. What's the 1/2? It's the base. What's this? Exponent, which includes an h shift. Yep. And then what about this? K shift. Yeah. Okay. Cool. So first things first, we got 2. Build a table. What helps me know where to start building a table? Yep, x minus 1 equals 0. What does x equal? 1. 2 numbers to the left of 1. 2 numbers to the right. Perfect. Plug those in. So we should get 18 when we plug in -1. So again, when you type that in, 4 parenthesis 1/2 close parenthesis caret to the -1 minus 1 in parentheses, and then plus 2. You should get 18. All right, and then when you go and change that to a 0, you should get 10. When you put a 1, you should get 6. When you put a 2, 4, and when it becomes 3, 3. Anybody not get that? Okay, now we just go ahead and we plot these points. the -1, 18 is going to be way up here, so I'm not even going to worry about that one. Okay. So now I've got these points right here. Okay. What is my asymptote going to be on this one? I heard 2 and I heard 3. Where are we getting 2? The k value is our horizontal asymptote, right? Y equals 2. Not 3. I don't know where we got 3. Okay, so it's going to look like that. Domain's going to be what? Negative infinity, positive infinity, range 2 to infinity. We put our approaches as negative infinity, positive infinity as x goes to the left. Okay, so let's visualize this for some of us who are still stuck on this. As x goes left, what's y doing? Up to infinity. Okay, now as x goes to the right, what's y doing? Stopping at the 2. Yep. There's a wall right there. You cannot go any further. Increasing or decreasing? Decreasing, right? Increasing, we just put none. X-intercept? Is this going to cross the x-axis ever? No. Good, we got off easy. Y-intercept? 0, 10. Okay, and then it says identify the shifts compared to the parent graph. Okay, this one actually has all 3. Okay, it's got the most that we could have. We start with the A value, which is what? 4, which tells us to stretch 4. The 1/2 is just the base, so it's not telling me anything. Is there anything written with my exponent?
Yes.
Yeah, what? A -1, which means to go right 1, good. And up 2. You got it. Not too bad, right? Just tedious. Okay. Number 7. I think this is the last one, isn't it? Let's go ahead and just to save time, we'll go ahead and we'll go through this one together, okay? First off, how do we start these? Yep, start with a chart. What's going to go in the middle? -4. You set the exponent equal to 0. It gives us -4. Now what? Okay, what are they? Perfect. Okay, now what? Plug them in, plug them in. So everybody be trying that. When you plug in -6, what do you get? -5? -4? -3? -2. Good. Okay, so now we go ahead and we quickly plot those points. This one's going to be a little different than what we've seen before, isn't it? Okay. So then we have a line that looks like this. Our asymptote's going to be where? Yep, the -5. So again, that's our K. Y is -5. No vertical asymptote, right? Domain's going to be Negative infinity to infinity. Range. -5 to infinity. As x goes to the left, what's y doing? Yep, ending at -5. As x goes to the right, what's y doing? Infinity. Is this increasing or decreasing? Increasing the whole time. Never decreasing. Do we have an x-intercept? We do, don't we? We gotta find it. How would I set that up? Okay, and then do what? Add 5. Make a log. Base of a value equals. What would I type in my calculator? Log 5 divided by log 3. Round that for me and tell me what that is. .46 equals x plus 4, but I'm not quite done. I still need to subtract 4. What is 1.46 minus 4? Comma 0. And then lastly, y-intercept. Don't know that either, but that one's a little easier to find. What do? Just plug in 0. So what is 3 to the 4th power minus 5? 76. 0, comma 76. I like it. Identify the parent shifts. Left 4 and down 5. Perfect. Questions on that? How we feel about today? Scale of 1 to 10.
9.
Tired? That wasn't on the scale. 9 and 10s? We feel okay? All right, good deal.